In October 1911, the sugarcane crop in Queensland, Australia was going to fail. Desperate to prevent economic catastrophe, the government of Queensland petitioned the US Department of Agriculture to send a scientist to figure out what was going on. So it was that Alexandre Arsène Girault, a young acclaimed entomologist stationed at the University of Illinois, got on a boat and sailed to the land down under. Girault spent 3 years in Australia, ostensibly researching the cane beetle, a voracious pest of sugarcane plants. But the bugs that captured his heart were the parasitoid micro-wasps, tiny insects which lay their eggs on or within other insects and whose offspring consume their hosts from the inside out. Girault collected these creatures with a net, by breeding, and by scanning windows for any little moving specks. Many of the wasps he caught this way had never been studied before. Nobody in all of Australia, nobody in the entire world even had a name for them, let alone any knowledge about their lives. So, Girault took it upon himself to classify them. One of these wasps he named Anagroidea. Over the ditch, and a century later, I was out searching for parasitoid wasps in the northern reaches of New Zealand, and I found Anagroidea too. In fact, Anagroidea was one of the most common wasps in my forests, so everything that Girault and his successors had learned about this particular creature suddenly became immensely valuable to me. So, let's look closely at Anagroidea. At a glance, it's not obvious that it's a wasp at all. It's definitely an insect. It has 6 legs, 4 wings, an exoskeleton, a couple of antennae. But a wasp? One of these colourful, vicious creatures that make nests and sting you? Anagroidea is tiny and hairy and has massive red eyes. You'd be forgiven for thinking it was a fly, or just some other weird tiny bug creature. But Girault knew that it was a wasp because of its waist. Wasps are characterized by a particular constriction between the middle and hind segments of their body. You can see this constriction in hornets and yellowjackets, you can see it in cuckoo wasps, you can see it in bees and in ants, both of which are also secretly wasps, and you can see it in parasitoids. Now, in particular, Anagroidea belongs to the family Mymaridae, which are colloquially known as the fairy flies, but they're not flies, they're wasps. Girault's project, published in 1915, was purely descriptive. He made no ecological claims, but his classification of Anagroidea as a fairy fly gives us a starting point. Fairy flies are known for being small. The smallest insect in the world, measuring just 150 micrometers, is a fairy fly. The typical ecological strategy of fairy flies is to parasitize the eggs of other insects. They are so small that they are able to use their ovipositor, which is equivalent to the stinger in a bee or a hornet, to inject their eggs inside other insect eggs, where the fairy fly larvae will hatch, kill the host embryo, and take over its food supply. Our friend Anagroidea is large for a fairy fly, measuring, if we're feeling generous, a whole millimeter in length. A particularly noteworthy character of Anagroidea is, to quote Girault, its slender bidentate mandibles. Bidentate just means has 2 teeth, which you can see clearly in the photos I've taken here. It has these 2 inward-facing mandibles, each with 2 prongs. So, okay, why does a tiny wasp need such big teeth? Well, let's return to our friend Girault. After World War I, Girault fell on hard times. He returned to Australia in 1917, this time to settle down for good. But the post-war economic climate meant entomological employment was hard to come by. Often unemployed or working jobs unrelated to his profession, Girault grew increasingly eccentric. He started forcefully including poetry, social commentary, and scathing criticisms of his colleagues in his scientific publications, to the point that his work was deemed unpublishable. Antisocial and anti-capitalist, he isolated himself from his peers and began self-publishing his taxonomic work. At the time, the entomological community was divided on whether any of his research could even be considered valid. Then, in 1931, after a prolonged battle, Girault's wife passed away from tuberculosis and he began to spiral. He became increasingly captured by paranoia and delusion. He was first committed to a mental asylum in 1936, and in 1941, in a different mental asylum, Girault died, only 57 years old. The cause of death was recorded as exhaustion and paraphrenia, and he was buried in an unmarked grave. As far as I can tell, Girault never revisited Anagroidea. He studied thousands upon thousands of wasps, and Anagroidea was just another drop in the well. So, after his death, the trail went cold for 25 years. Then, in 1972, a team of 3 entomologists, Yoshimoto, Sergei Trjapitzyn, and Vladimir Berezovskiy, described a new wasp genus, Eubroncus. If you thought Anagroidea had big mandibles, get a load of this guy. Terrifying, maybe, but if you can look past the mandibles, you'll notice some similarities. This wasp, it turns out, belongs to the same subfamily as and is the closest known relative of Anagroidea. 3 years later, citing the Eubroncus paper, entomologist Richard Doutt, who was at the time the acting dean of the College of Agricultural Sciences at the University of California, Berkeley, described another wasp in the subfamily, Dahmsia, named after E.C. Dahms, who was at the time the curator of entomology at the Queensland Museum. But remember, Queensland was also where Girault was working. Dahmsia was caught by sweep netting at Minion Falls, just south of Brisbane. In fact, if we look at the taxonomic sketches in Doutt's paper, we may find that they look eerily familiar. In 1989, Noyes and Valentine published a comprehensive monograph of the fairy flies of New Zealand, wherein they synonymized Dahmsia and Anagroidea. These are actually the same genus of wasp, and since Girault was first, his name is the one that sticks. To this day, Noyes and Valentine's monograph remains the most comprehensive treatment of the group for New Zealand species. So, what do they have to say? There are as many as 4 different species of Anagroidea wasp in New Zealand, distributed across the north, South, and Three Kings Islands. The biology section is positively enlightening. It cuts to the heart of the matter. It reads simply, biology unknown. 70 years had gone by, and nothing at all had been learned. After Noyes and Valentine, a scattering of papers were published that added new species of Anagroidea to the map. Anagroidea are commonly found in Asian and Australasian countries like New Zealand, Australia, India, Korea, and Taiwan. Anagroidea have also been found in Russia and across the ocean in the southeast of the USA. Most of these papers are simple checklists, but there is one final critical study to discuss. In the year 2002, Sergei Trjapitzin and Vladimir Berezovskiy, who were both co-authors on the original Eubroncus paper, published a review of the Eubroncus and the Anagroidea of Russia. Here's what they have to say about Anagroidea's biology. Quote, the biology and hosts of Anagroidea and Eubroncus are unknown. Yoshimoto et al., 1972, supposed that Eubroncus species might be specialized parasitoids of flattened insect eggs. We can add that such an egg would likely have a very strong chorion, considering the well-developed mandibles in Anagroidea and especially large ones in Eubroncus. Now, the chorion is the outer shell of the insect egg, which protects it and gives it structure. Some insects will have very flimsy chorions, and others will have very strong, robust chorion. This is important because, remember, egg parasitoids like Anagroidea and Eubroncus have to chew their way out of the egg after they've pupated and become adults. There are cases of other Mymarids parasitizing the wrong egg, growing into adults, and then becoming trapped inside the very egg which allowed them to grow because the chorion is too tough for them to break out of. Not so if you're an Anagroidea, you're a Eubroncus. You can chew your way out of that tough eggshell with your enlarged mandibles. To continue, quote, the strong body sclerotization and presence of a short ovipositor indicate that females of Anagroidea and Eubroncus may search for more or less free-laying or just slightly concealed host eggs in leaf litter or upper soil. So once they chew their way out of their host egg, adult Anagroidea mate and then set about looking for a new generation of eggs in the leaf litter, which explains why they're so prone to being caught in pan traps. Orthopterans, like grasshoppers or katydids, are very plausible hosts. By all accounts, their eggs match the criteria, but it remains that I cannot find any evidence that anyone has ever tested this. In the absence of verification, this is all simply speculative. And that, I'm afraid, is the end of the line. Since 2002, no meaningful research has been published about Anagroidea that I can find. There is an awful lot of unpublished knowledge bouncing around in the heads of entomologists, so maybe there's someone out there who knows more. Since publishing his Anagroidea review, Sergei Trjapitzin has gone on to become the director of the Entomology Research Museum at the University of California, Riverside. If you're watching this and you are Sergei Trjapitzin, first of all, I'm honored and terribly sorry for butchering your name. And second, please leave a comment, I suppose, if you've learned anything more about Anagroidea in the last couple of decades since you published. To the rest of you, thank you for joining me in the story of Anagroidea, heavy-duty fairy fly. It has been more than a century since Anagroidea was described, and we haven't managed to do much more than speculate about its place in the natural world. If you live in a place like New Zealand or Australia, though, they're really common. They're all over the place. You could very well have some in your garden. If you also happen to have a microscope and the ability to rear parasitoids, you could answer this scientific mystery and find out for sure. Thank you to my wonderful channel members, and I'll see you all in the next one.